Hey guys, these next two videos are going to be focusing on solving inequalities, and on this first one we're going to be focusing on polynomials. Hey guys and welcome back, this is Franck, and today we're going to be talking about how to solve polynomial inequalities. And if you've not done so yet, go ahead and subscribe to the channel so you can get more videos like this one. And so with that, let's just move into the video. And so the first thing I should mention here is that I'm going to be solving polynomial inequalities in 3 steps. The first thing is going to be for me to move everything on one side of the inequality. Then the second thing I'm going to do is find the zeros. Those are going to be serving as my boundaries. And I'm going to do those by factoring the polynomial itself. And then the last thing I'm going to do here is to draw the number line so I can figure out exactly what portion of my number line is part of the solution and which ones are not. So this process is going to be very similar to what we've done in Note 17 when we were solving absolute value inequalities. And so with that, let's jump to the first example. So I'm going to have here x minus 4 in parentheses, x plus 2 bigger than 0. So your job here is to find all the x values such that this particular polynomial is going to be strictly positive. And so as you can see here, the first step is already done. Everything is moved on one side of the inequality, so there's nothing to do there. My second step here is going to be to find the zeros. And so with that, since my polynomial is already factored, I can just read off what the zeros are directly without doing any more work. And so from x minus 4, I know that x should be equal to 4. And from x plus 2, I know that x should be equal to negative 2. And both of these zeros happens to have a multiplicity of 1, which means that they happen only one time. And that's going to be important when I go to step 3, because as you remember, if your multiplicity happens to be odd, what you're going to do is you're going to cross the x-axis as you get close to that 0. What that means is that the polynomial itself is going to be changing sign from being positive to negative or negative to positive. Okay, so let me draw the number line here, and I'm going to go ahead and put my zeros on, negative 2 and 4. And then next thing we need to do here is try to figure out which regions out of those 3 regions are actually solution for my inequality. So I'm going to go ahead and test the region so I can know whether they work or not. The easiest thing to do here, since you know that the sign is going to be changing at negative 2 and 4, you can go ahead and just test 0. So I'm going to go ahead and plug 0 into my inequality here. If I do that, I'm going to get 0 minus 4 in parentheses, and then I'm going to get 0 plus 2 in parentheses. And if you multiply these two together, you're going to get negative 8, which is negative, which means that it does not satisfy my inequality. And so for that, I'm going to go ahead and put a negative here between negative 2 and 4, because that's where the 0 test point is coming from. And so with that, you could also go ahead and just pick different test points between negative infinity and negative 2, and between 4 and positive infinity. But the simple trick here to go faster is just to notice that negative 2 and 4 have multiplicity 1, which means that the sign is going to be changing as you go through them. And so, since the middle here happens to be negative, if you go towards negative 2, you will pass negative 2 and change sign. And so that's going to be positive. And the same thing is going to happen with 4 here. When you cross 4, you're going to be changing signs as well. And so that's going to be positive as well. So you can either find test point within your region to test them to see which sign your number line is going to get, or you can just use the multiplicity trick to figure out which sign is the region going to adopt when it comes to the polynomial itself. So in this case, since we are looking for portions of our number line that will make the polynomial strictly bigger than 0, our solution is simply going to be from negative infinity to negative 2, open parentheses, and from 4 to infinity, both open parentheses, right? Because those portions of our number lines happen to be positive. And since we want strictly positive, we don't want to include negative 2 and 4. That's why I have open parentheses on negative 2 and open parentheses on 4 as well. And so with that, this particular inequality problem would be solved. All right, let me give you a next one. The next one is going to be x to the power of 3 in parentheses, x minus 2 to the power of 2, and then in parentheses, x plus 4. And I want that to be less than or equal to 0. Again, I'm going to do the same thing that I did before. Step 1 is to move everything on one side of the inequality. That's already done here. Next step is to find a 0 by factoring the polynomial. But since this polynomial is already factored, that will be an easy step. So I can just go ahead and set each of the factors equal to 0 so I can figure out what makes the polynomial 0. For my first factor, x cubed, I know that x should be equal to 0. And that should happen 3 times because the x is being cubed. So my multiplicity here is going to be m equals to 3. For my second factor here, x minus 2 all the way squared, my x should be equal to 2 with a multiplicity of 2. And for the last one here, x plus 4 equals to 0 means that x should be equal to negative 4 with multiplicity 1. And so from this, I'm going to draw my number line here, and I'm going to put all my zeros in. Negative 4, 0, and 2. And from the previous work, I also know that I'm going to have a sign change at negative 4 because the multiplicity is odd. I am going to have a sign change at 0 for the same reason, but I'm not going to have a sign change at 2 because the multiplicity is even. So the polynomial itself is going to be bouncing off the 0 as a parabola as it gets to it. So there's going to be no sign change there. All right, with that known, we're going to go ahead and just test a point in either of these regions. So I'm going to go ahead and pick 1 between 0 and 2. So if I go ahead and test 1 here, 1 cubed is just going to be 1. And 1 minus 2 squared is just going to be 1 as well. And then after that, I have 1 plus 4. That's going to be 5. And so multiplying all these would just simply give me 5, which happens to be bigger than 0. So the region between 0 and 2 would have a positive sign. And so since I know the sign of this region, I can just auto-complete the sign of the other region, keeping in mind the multiplicity of those zeros. So when I go through 0, the sign is going to change to negative. And when I go through negative 4, the sign is going to change again to positive. But when I go through 2, the sign is going to stay the same, and it's going to be still positive. Because remember, the graph is going to be bouncing back to the positive region as it gets to 2, because the multiplicity happens to be even. All right, and so since I'm looking for the portion of my number line where the sign happens to be negative, then my solution here is going to be from negative 4 to 0. And since I want them to be negative or equal to 0, I'm going to go ahead and include negative 4 and 0. So that's why I have close brackets here to say that negative 4 and 0 are also part of the solution. Okay, so those are 2 examples where the polynomial is already factored, so it's easy to find the zeros. Let me give you more examples where the polynomial is not factored already, and you have to actually go ahead and find the actual zeros in order to continue. So my third example here is going to be x cubed plus 2x squared minus x minus 2 bigger than or equal to 0. And so with this, my first step is already done because everything is moved on one side. My second step is going to be to find the zeros of this polynomial. It's the polynomial of degree 3, which is going to be harder to do. So I'm going to have to go ahead and use some techniques to figure out what one of my zero is in order to factor this guy out. And so if you remember from note 40, we talked about how to find the zeros of a polynomial. So if you want a refresher on that, on the rational zero theorem or the Descartes rule of sign, go ahead and check that out. And for this particular one here, I'm going to go ahead and start with the rational zero theorem. So since all of my coefficient here happens to be integers, if some of my zeros are in rational form, they have to be in the form p over q, where p has to be a factor of negative 2 and q has to be a factor of 1, which means that some of my possible zeros here are going to be plus or minus 1 or plus or minus 2. And so with that, I can go ahead and start checking these out to see if some of these works. And so starting with 1 here, if I go ahead and plug 1 into my polynomial, I'm going to get 1 cubed is just 1, plus 2 times 1 squared is going to be 2, minus 1 minus 2. And that's going to give me 0, which is good because it means that I found a particular 0 for this polynomial. And so now I can go ahead and use synthetic division to figure out what my other factors are. Synthetic division has been talked about in note 39, so you can also go ahead and check that one out. And so I'm going to have 1 here in the corner. Then I'm going to have the coefficient of my polynomials here. It's going to be 1, 2, negative 1, and negative 2. So from there, I can go ahead and start the process. I'm going to bring the 1 down. That's going to be 1. And then 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. Negative 1 plus 3 is 2. And then 2 times 1 is 2. And finally, negative 2 plus 2 is 0, of course. All right, so with this, I know that I can rewrite my polynomial as x minus 1 in parentheses. And these three numbers here serve as the coefficient for my other factor. So I'm going to have x squared plus 3x plus 2. And so since I have a quadratic now, I can just go ahead and factor it further because I know how to factor quadratic. So that's going to be x minus 1 here. And here I'm going to be looking for two numbers that are adding up to 3 and multiplying to 2. That's going to be 1 and 2. So I'm going to have x plus 1 here and x plus 2 here. With that, I can finally say that my zeros are going to be x equals 1, x equals negative 1, and x equals negative 2, coming from each of the factors that I have here. And of course, each of those have multiplicity 1, which means that the sign is going to change every time you go past a 0. So on my number line here, I'm going to go ahead and put them in order. So I'm going to have negative 2, negative 1, and 1. I'm going to go ahead and test 0. That's between negative 1 and 1 because that's the easiest point to test. And so if you plug in 0 into your polynomial, you find that that's going to give you negative 2. And negative 2 happens to be negative. So I'm going to put a negative sign here. I'm going to complete the other side. So if I go past negative 1, the sign becomes positive. And if I pass negative 2, the sign becomes negative. And then if I go past 1 here, the sign becomes positive. Therefore, since I'm looking for places where the polynomial is bigger than or equal to 0, I'm going to be looking for all the positive region in this particular number line, including the endpoints. So I'm going to have here negative 2, close bracket, to negative 1, close bracket, and I'm going to have 1 to infinity, close bracket at 1, and open bracket at infinity because you never close infinity, because it goes on forever, forever and ever. All right, so let me give you one last example where I actually have to do all three steps. So this one example is going to be x cubed less than 4x squared. That's simple. All right, so I'm going to go and do the first step here is to move everything on one side. So I'm going to subtract 4x squared on both sides. That's going to give me x cubed minus 4x squared less than 0. Then I'm going to move to step 2, which is to figure out what the zeros are. So since this particular polynomial happens to have x squared as a common factor, I can go ahead and pull that out. So I'm going to have x squared here, and in parentheses, I'm going to have x minus 4 less than 0. Next, I'm going to go ahead and set them equal to 0. So from the first factor, x squared here, another x should be equal to 0 with multiplicity 2. And from x minus 4 here, another x should be equal to 4 with multiplicity 1. As I put them on my number line here, I'm going to put 0 here, and I'm going to put 4 here. And I know that my sign is going to change when I go past 4, but it's going to stay the same when I go past 0. And so I can go ahead here and pick a test point. That's going to be 1 for me. I'm going to plug 1 into my inequality on top here. So I'm going to have 1 cubed is 1 minus 4, 1 squared happens to be negative 4. And so if you subtract these two, you're going to get negative 3, which happens to be negative. So I'm going to put a negative sign here in the region between 0 and 4. Finally, I can go ahead and put a negative after I pass 0 because the sign doesn't change. And I'm going to go and put a positive when I pass 4 because the sign does change. And since I'm looking for a portion where the polynomial happens to be strictly negative, I'm going to go ahead and get it from negative infinity all the way to 0, open parentheses in both cases, and from 0 to 4, open parentheses in both cases. Notice here that I didn't go from negative infinity to 4 directly because it's strictly less than 0. And so 0 itself has to be excluded from this particular solution, and so does 4. And so you have to make a little stop here between negative infinity and 4 for your solution to be 100% correct. And with that, ladies and gentlemen, we are done. And so next time, I'm going to be talking about how to solve rational inequalities. And as usual, if you would like a copy of this note, check out the descriptions below. And if you like the way I break down the material, give me a thumbs up, and I will see you next time. Bye-bye.